So good morning students, welcome back. Today in 11th class, we are going to start lesson number 3rd, okay, motion in a straight line. So today in this lecture, we are going to discuss some basic terms. So let's start with the rest and motion. So first of all, we are going to discuss two topics, rest and motion. So simple thing, what is the meaning of rest? An object is said to be in rest when it does not change its position, okay, with respect to time and surrounding. When object does not change, look at, see my position, 1 second, 2 second, 3 second, 4 second, time is going on, okay, with respect to time, I am not changing my position, so I am in the state of rest, okay. So what is the meaning of rest? When object does not change its position, okay, with respect to time and surrounding, it is said to be the state of rest. Look at, suppose this is an object, okay, and time is going like 1 second, 2 second, that is a position. This object cannot change its position with respect to time, 1 second, 2 second, 3 second, 4 second, 5 second, okay. So suppose A is reference point, A is surrounding point, initial point, and the object cannot change its position with respect to A point, okay, with respect to time. So object is said to be in the state of rest. On other hand, what is the meaning of motion? When object can change its position with respect to time and surrounding, it is said to be in the state of motion. Look at, I'm in the state of motion. Why? Look at, this is surrounding, this is the reference point, okay, 1 second, 2 second, 3 second. I can change my position with respect to time and surrounding. So I am in the state of motion. Okay, students? So when an object cannot change its position with respect to time and surrounding, it is in the state of rest. While in case of motion, suppose an object can change its position with respect to time and surrounding, that is in the state of motion. An object, okay, at 1 second it was at A point. After 2 seconds, the object reached at B point. So that object is said to be in the state of motion. Okay, students? So now, students, a marker is placed like this. It is said to be in the state of rest. Okay, when I walk, I am in this state of motion. So that is the meaning of rest and motion. Okay, now, students, now we'll start the types of motion. Okay. Types of motion. Okay, basically it is classified in 3 parts: one-dimensional motion, two-dimensional motion, and three-dimensional motion. There are different type also, like rectilinear motion, okay, that is circular motion, rotational motion, simple harmonic motion. Later on we'll discuss about that, but here we are going to discuss basic 3 terms. First of all is one-dimension motion. What is the meaning of one-dimensional motion? When object travel, okay, when an object executes its motion only along one axis, okay, these are the 3 axes X, Y, Z. Suppose an object is traveling along X axis, along a single any axis, such motion is said to be one-dimensional motion. Motion of train on track, that is also an example of one-dimensional motion. When I walk, that is also example of one-dimensional motion. When we walk, when we run, okay, these are the example of one-dimensional motion because we execute motion along in a single any axis. So when an object executes motion along any one single axis, that is said to be one-dimensional motion. A simple example, a man is walking on road, okay, that is a simple example. Either the motion of train or tracks, that is called one dimension. Now second is two-dimension motion. What is two-dimensional motion? When object travel along X and suppose Y axis, we can take any 2 axes, but if the motion executes, if the object executes motion along 2 axes, such motion is said to be two-dimensional motion. I'll give example. The movement of football player in that ground is said to be two-dimensional motion. Okay, the motion of that strikers on carom board is also the example of two-dimensional motion, because in carom board the strikers travel along x and y. It follows the two axes. Even in football player, that also its movement along that ground along two axes. So such motion is said to be two-dimensional motion. Okay. Now finally we discuss about three-dimension motion. What is the meaning of three-dimensional motion? Obvious, when an object travels the distance along x, y and z axis, its motion, it executing motion along all three axes. It included all three axes along x, y, z axis. Such motion is said to be three-dimensional motion. I'll give you example: the motion of aeroplane. Okay, the motion to fly a kite. Okay, the most example, the motion of fish, distance and displacement. Okay, I will explain with the help of a diagram. Okay, suppose A is the initial point of motion and B is the final point of motion. A student follow two paths. Okay, suppose A is home and B is school. That student following two paths. First student move from this path. This is the first path. Another student using this second path. Okay, first student is using this path and second student is using that path. Okay, with the same point. This is the initial point and that is final point. So total path is said to be, total path traveled by an object is said to be distance. So this is said to be distance. Okay, the second path is said to be distance. On other hand, the shortest path, the minimum path between initial and final position is said to be, yes, it is said to be displacement. Total path is said to be distance and the shortest or minimum path between 2 points is said to be displacement. So we can say first is said to be displacement and second path is said to be distance. Okay, now students, distance is a scalar quantity and displacement is a vector quantity. You did it in small classes, but we'll discuss in 4th chapter in vector. Actually, those physical quantities that required only magnitude, only mathematical value, there will be no need of direction to represent it. That is said to be scalar. Okay, the example is mass, like distance. Okay, we can take speed. Okay, a lots of examples are there. On other hand, what is vector? Those physical quantities that require magnitude as well as direction to complete representation is said to be vector. Okay, velocity is displacement, acceleration, force. A lots of examples are there. So that we'll discuss in that further chapter. So distance is scalar quantity and displacement is a vector quantity. What is the unit of distance? Generally we measure in meter and displacement also in meter. We can also take centimeter in CGS, meter in MKS. We can also represent by kilometer also. So distance is a, what is distance? Total path traveled by an object is said to be distance. It is scalar quantity, the unit is meter. On the other hand, the shortest or minimum path between 2 points is said to be displacement. Okay, it is a vector quantity, unit meter. Okay, now students, I will give example. Okay, small numerical we will discuss to distinguish between distance and displacement. So I will give example. So look at students. A small numericals are there. Suppose an object is following this path A, B, C and D. The object is following the circular path. Okay, this is an example of circular motion. Okay, when object travel along straight path, that is called linear motion. When it follows the circular path, it is called circular motion. Okay, so now students, the radius of that path is capital R. Understood? This is center. Now we define, first of all, distance. Okay, and second, we have to find displacement from A to C, from A to C. First of all, from A to C, what will be distance and what will be displacement? So we know distance is what? Total path. So this total path from A to C, that is half circumference. So 2 pi r by 2 means what? Pi r. This is said to be, radius is r, we can take capital R. If you want to take small r, you can write. This is half circumference. 2 pi r by 2 means what? Pi r. This is said to be distance. And what is displacement from A to C? As I told, the displacement is what? Minimum or shortest path from initial to final point. This is said to be minimum. So r plus r, that is diameter. So diameter is what? R plus r, that is what? 2r. So 2r is said to be displacement and pi r is said to be distance. Understood? If we have to find displacement from A to A, now from A to A, what is distance? That is total circumference. So that's why here we write as 2 pi r. Understood? And what will be displacement? From A to A. From A to A. Initial and final point is same. So displacement will be what? 0. It means distance is always positive, but displacement may be positive, may be negative, or sometime 0, because initial and final point is same. So that is a small description, basic idea of this chapter, motion in a straight line. Okay, students?